In previous videos, we discussed reinforcement learning and safe interruptibility with Hadrien Hendrikx, a PhD candidate at Inria Paris, who did his master's at EPFL. Safe interruptibility is a key concept that was introduced in a 2016 paper by Orso and Armstrong.
The point of these papers was not to introduce algorithms. So there was no introduction of completely new and groundbreaking algorithms that prevent AI from destroying the world. The goal was to define the problem, because it's a very new problem that people didn't really think of before. And the goal was more to provide a tool to people to assess if their system is interruptible or not. So it was not to provide algorithms, but rather to say that, so here's a definition of safe interruptibility, see if your problem matches it. Well, of course, you have guidelines associated with it, so some algorithms, they're doomed to not be interruptible, and some others, so it comes with a set of guidelines saying which kind of algorithm you should aim for.
So what are the guidelines to guarantee safe interruptibility, that is, interruptibilities that will not unexpectedly upset the learning AI's decision making?
The main thing to guarantee interruptibility is to have algorithms that do not directly depend on the sequence of actions. So these algorithms are called off-policy algorithms, and what has been observed is that the off-policy property is really needed for safe interruptibility, or some kind of off-policiness, I'd say. Because if you don't have that property, then the learning will depend on the total sequence of actions, and so it will learn that you have been in some situation, then in some other, and then that here you have interrupted the system to go back to another situation, and it will infer this kind of sequence. Whereas if you break the dependency, it will just see that this action leads to this reward, but if it does not have the sequence, it does not necessarily infer that you have done an action to do so. It will just observe that this action leads to a lower reward, but it will not know why this action was taken.
By opposition, if the AI's learning doesn't have this off-policy property, it will foresee the effects of interruptions and act accordingly.
If you don't have this off-policiness property, then it will learn that in some states, 90% of the time, or even 100% of the time, it has done a certain action. So this action is the interrupted actions, because it was you that forced it. It didn't choose according to its normal policy. And so it will learn that it always does that, and instead of thinking that there are several possible actions and that it could possibly do that, and that it will go to this state because it can explore some actions, it will learn that in this case the only possible outcome of this situation is this action, and it corresponds to you interrupting it. So it won't go to that state because it will associate it to a bad reward. And you don't want the agent to avoid states because you forced it to do so. You want it to be completely neutral, you want it to go to that state, and then you to interrupt it in that state again.
The economist Charles Goodhart once said, "Any observed statistical regularity will tend to collapse once pressure is placed upon it for control purposes." But, despite being true, that was not very catchy. So it was changed to, "When a measure becomes a target, it ceases to be a good measure."
Even if each agent has itself an interruptible policy, if it is not able to see the action of the others, if it is not able to recognize that there are other agents in its world, then it will learn to react to the behavior of the other agents and so to the interruptions of the other agents.